me show the screen. Yeah. Hello, Professor. This is Hemant Kumar Kokula. Thanks for giving me the opportunity to do this project. So my project name is Moving Target Defense Approaches in Cybersecurity, and my teammate is Suraj Gantiala. So moving to the contents, these are the contents of my project. Let's get into the introduction. So basically, the cybersecurity is a battle between attackers and defenders in cyberspace, which is a never-ending one. Every organization contains flaws that an attacker can take advantage of or to obtain access and to do harm. So these security holes must be identified and exploited and fixed by a cyber attacker, while cyber defenders must close them. So basically, an attacker finds the loopholes and tries to attack a software, but a defender must identify the problem and close them. So below image is an illustration of cybersecurity defense, as it shows a building or a palace is covered by different security sources like inner walls, watchtower, limited entry points, gas check identity, high hard walls, and a moat. So it basically shows the security system and or the defense system across the building. So moving on, the current cyber security issues, the defense paradigm, it is passive and it's reactive. In terms of resources and cost, this is uneven, and attackers have the advantage to hack softwares easily. So these are the basic cyber security issues which are faced. And let's moving on to next slide. Moving target defense approaches based on a system diversity are like we need to make the switch from standalone software to a network-based solution, and dynamically changing the software or system configuration to add uncertainty to the software helps a attacker to avoid attacking the software, and change the attack surface of the system on a regular basis helps attackers not to attack the software and increase the cost of the attackers. As a result, attackers will find the system unexpected, difficult to exploit, and more resistant to attacks. So moving on to the next slide, my teammate Suraj will continue with the PPT.
Hello, Professor. This is Suraj Gantiala. Okay, let me continue the PPT from MTD approach in system level. Coming to the system level, we will be having total 3 softwares. One is ASLR, data randomization, and compiler-based randomization. Coming to ASLR, it is nothing but address-based layout randomization. It is primarily used to protect against buffer overflow attacks, and it is proposed and implemented by Linux PAX project in 2001. Coming to the OS, it is implemented in major OS systems partially and completely, and can be prevented. Code injection attack might be broken by entropy attack. This is all about ASLR, address-based layout randomization. Coming to the next one, it is data randomization. It is nothing but randomization pointers, that is XOR pointer with random keys, and randomized memory data, it is XOR data with random mask. And compiler-based animation is nothing but it uses compiler to generate multiple functionality equivalent but internally different variants of a program. This was all about MTD approach in system level. Coming to MTD approach in application level, the first one is diversify and randomize software using installer. Using installer, we'll be downloading diversify and randomization software. And software is installed through specific installer will be tagged with a random key. Every software which we're gonna the software which we're gonna install through an installer will be having the random key, and execution environment will check and verify that random key which we get while installing, and it is only authorized and executed if key is valid. If key is not valid, the software will be not running. It is all It is about MTD in application level. Coming to MTD in network level, in total, we will be having two things: dynamic resource mapping system and random host mutation. MTD network level deals with location. Okay, MTD network level dealing with dynamic resource mapping system. It is nothing but it randomly changes the location of the system where important resources are stored. And the mapping system keeps track of new locations. And coming to the random host mutation, it is same as dynamic resource mapping system, but here it randomly changes the host IP address. Whereas coming to the challenges faced by MTD while doing this project, we have came across many challenges, and we have listed top three challenges which we have faced. The MTD software is easily deployable. The first one is it is easily deployable, and coming to the second one, the minimum impact on mission critical system. MTD has the minimum impact on mission critical system. And coming to the third one, MTD is scalable. These are the three challenges which we faced while doing this project. Here we complete the slides. Thank you for this opportunity, Professor. This is all about MTD, which we have done research on.